Hello students, today we will discuss on absolute and relative permittivity. We know that force between the two charges separated by some distance in free space or vacuum is given by the expression that is 1 divided by 4 pi epsilon naught q1 q2 divided by r square, where we call this epsilon naught as permittivity. We call it as the permittivity in free space, or vacuum, and the value for this permittivity in the free space or vacuum is 8.854 into 10 to the power minus 12 Coulomb square per Newton per meter square. So this epsilon naught stands for the absolute permittivity. Epsilon naught means it is the absolute permittivity in free space or vacuum. When the permittivity in the medium is air or vacuum, then we will call it as the absolute. The permittivity which is air or vacuum, we call it as the absolute permittivity. If the medium is not air or vacuum, other than air or vacuum, then we will call it the relative permittivity, and it has a different values in different mediums. Now we will see what will be the relation between the absolute and relative permittivity. Right, we know that force between two charges, we know that force between two charges separated by some distance in air or vacuum, that is, I will call as the F vacuum, which is equal to 1 divided by 4 pi epsilon naught q1 q2 divided by r square, where this epsilon naught stands for the absolute permittivity in the free space or vacuum. Now the same two charges are placed in some medium, we'll call it the medium. Now force between two charges separated by same distance in medium is, I will call it as the F medium, which is not air or vacuum, and that is 1 divided by 4 pi, simply I will call it as the epsilon q1 q2 divided by r square. Right, so we have F vacuum, that is 1 by 4 pi epsilon naught q1 q2 divided by r square, and F medium is equal to 1 by 4 pi epsilon q1 q2 divided by r square, because the charges are separated by the same distance in the medium. So we will call this equation number 1 and equation number 2. Equation 1 and equation 2. Dividing 1 by 2. We will divide the equation 1 by 2. After dividing the equation 1 by 2, say that it is F vacuum divided by F medium. F vacuum divided by F medium. What I will get? I will get what? That is epsilon divided by epsilon naught. Epsilon divided by epsilon naught. That is the permittivity in the medium to the permittivity in the free space. Right? So this epsilon divided by epsilon naught. When we divide the equation 1 by 2, this 4 pi get cancelled. Q1 Q2 by r square, Q1 Q2 by r square get cancelled. What remains? This epsilon naught comes to the numerator. So this is epsilon divided by epsilon naught, which is called as epsilon r. This epsilon r is called the relative permittivity. This epsilon r is called the relative permittivity, and we define relative permittivity in this way, that is epsilon r, which is equal to epsilon divided by epsilon naught, called relative permittivity. Relative permittivity, or we call it as the dielectric constant. We call it as the dielectric constant. And we will write the definition of this. Definition ನಾವು ಈ ರೀತಿ ಹೇಳ್ಬೋದು. ಏನದಪ್ಪ ಇಲ್ಲಿ? ಎಪ್ಸಿಲಾನ್ ಆರ್ ಅಂತದ. ಎಪ್ಸಿಲಾನ್ ಆರ್ ಅಂದ್ರೆ ಏನು? ರಿಲೇಟಿವ್ ಪರ್ಮಿಟಿವಿಟಿ ಅಥವಾ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಕಾನ್ಸ್ಟಂಟ್. ಏನದ ಇಲ್ಲಿ? ಎಪ್ಸಿಲಾನ್ ಡಿವೈಡೆಡ್ ಬೈ ಎಪ್ಸಿಲಾನ್ ನಾಟ್. ಸೊ ಇಟ್ ಈಸ್ ದ ರೇಷಿಯೋ ಆಫ್ permittivity in the medium, to the permittivity in free space or vacuum. Right? This is the definition for the dielectric constant or relative permittivity. It is the ratio of permittivity in the medium to the permittivity in the free space or vacuum. Or in terms of force also we can define, that is F vacuum divided by F medium. It is the ratio of force between the two charges separated by some distance in air or vacuum to the force between the two charges separated by same distance in the medium. That is the dielectric constant or relative permittivity, and it is different for a different material. When we place a dielectric constant in the medium, then the force between the two charges decreases. Force between the two charges decreases, such as say that any glass plate, plastic sheet is placed in between the two charges, then this glass plate or the plastic sheet does not allow the charges to interact with them, so its force decreases. So whenever the dielectric constant is placed in between the two charges, the force between the charges decreases. Right? So remember these things. Now we'll talk about the definition of charge. Definition of Coulomb. We'll talk about the definition of Coulomb. Definition of Coulomb. So ಇದನ್ನ ನಿಮಗೆ ಎಕ್ಸಾಮ್ ದಲ್ಲಿ ಒಂದು ಮಾರ್ಕ್ಸ್ ಕೇಳ್ತಾರೆ. ಡಿಫೈನ್ SI ಯೂನಿಟ್ ಆಫ್ ಚಾರ್ಜ್, or define SI unit of charge. So this is the question asked in the examination for the 1 marks. Define Coulomb or define SI unit of charge. We know that F is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. Q1 Q2 divided by R square. Say if Q1 which is equal to Q2 which is equal to 1 Coulomb, say still we are not defined Coulomb. ನಾವು ಅದಕ್ಕೆ ಏನು ಮಾಡೋಣಪ್ಪ ಅಂದರೆ 1 Coulomb ಅಂತ ಹೇಳೋಣ. R is equal to 1 ಮೀಟರ್ ಅಂತ ಹೇಳೋಣ. R is equal to 1 ಮೀಟರ್ ಅಂತ ಹೇಳೋಣ. ಆವಾಗ ನಮಗೆ ಏನು ಸಿಗ್ತದಪ್ಪ ಅಂದರೆ F is equal to 1 divided by 4 pi epsilon naught 1 into 1 divided by 1 ಅಂತ ಸಿಗ್ತದೆ. We know the value of 1 by 4 pi epsilon naught. What is the value of 1 by 4 pi epsilon naught? So it is 9 into 10 to the power 9 Newton. Alright, if suppose say that Q1 is equal to Q2 is equal to 1 Coulomb and R is equal to 1 meter, we get the force that is 9 into 10 to the power 9. Using this we can define the Coulomb now. So 1 Coulomb is that a charge, 1 Coulomb is that a charge which repels equal and similar charge placed 1 meter apart in air or vacuum with a force of 9 into 10 to the power 9 Newton. So we can define here 1 Coulomb is that a charge which repels equal and similar charge placed 1 meter apart in free space or vacuum experiences a force of how much? 9 into 10 to the power 9 Newton. ಯಾವಾಗ ಎರಡು ಚಾರ್ಜಸ್ಸು ಸೇಮ್ ಸಿಮಿಲರ್ ಚಾರ್ಜಸ್ಸು 1 ಮೀಟರ್ ಡಿಸ್ಟೆನ್ಸ್ದಲ್ಲಿ ಇಟ್ಟಿರ್ತೀವಿ ಫ್ರೀ ಸ್ಪೇಸ್ದಾಗ ಅಥವಾ ವ್ಯಾಕ್ಯೂಮ್ದಲ್ಲಿ, ಆವಾಗ ಅವು ಎರಡೂ ಚಾರ್ಜಸ್ಸು ಫೋರ್ಸನ್ನು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡ್ತಾವೆ. ಎಷ್ಟು ಫೋರ್ಸ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡ್ತವಪ್ಪ ಅಂದರೆ 9 into 10 to the power 9 Newton. 1 ಮಾರ್ಕ್ಸಿಗೆ ನಿಮಗೆ ಎಕ್ಸಾಮ್ದಲ್ಲಿ ಕೇಳ್ತಾರೆ ಏನಪ್ಪ ಅಂದರೆ ಡಿಫೈನ್ SI ಯೂನಿಟ್ ಆಫ್ ಚಾರ್ಜ್ ಆರ್ ಡಿಫೈನ್ ಕೂಲಮ್ ಅಂತ. ಸೊ ಇಷ್ಟು ಮಾತ್ರ ನೀವು ಬರೆದ್ರೆ ನಿಮ್ಗೆ 1 ಮಾರ್ಕ್ಸ್ ಸಿಗ್ತದೆ. ಅದ್ರಾಗ ನೀವು ವರ್ಡ್ಸನ್ನು ಹಾಕಿರ್ಬೇಕು ಏನಪ್ಪ ಅಂದರೆ ಫ್ರೀ ಸ್ಪೇಸ್ ಆರ್ ವ್ಯಾಕ್ಯೂಮ್ ಅನ್ನೋಂಥದ್ದು. ರೈಟ್. ಸೊ 1 Coulomb is that a charge which repels when equal and similar charge placed 1 meter apart in free space or vacuum experiences a force of 9 into 10 to the power 9 Newton.